Hi, good morning. It's Jim from the Mavestar Observatory. Oh dear me guys, have we made some massive errors in our judgments over these years in calculating what's going on with the climate. You know, we are not going to know, most of us, until it has already happened, you know, with regards to a glacial maximum, which last occurred around 18,000 years ago, and we came out of that glacial maximum around 12,000 years ago. And a bit later on I'm going to show you how close we are as to going back into one. But you know, we've made some terrible miscalculations which have led to some bad judgments, in my opinion. You can't you know, calculate global temperatures by, you know, the means of which they have done over the last 10, 15, 20 years. And the way they take the temperature of the Earth is from different locations all around the world. They'd put it on a chart and draw an average line. It's called the GMST, or, you know, global mean surface temperature. And you would have an average of temperatures all around the world. But the point is, you can't apply that GMST to any one particular location because it's made up of different locations. Another thing which they've done terribly wrong is, you know, go on you know, ice core samples such as that was taken in the Vostok Antarctica research facility and apply that to global temperatures on the whole. You can't do that because, you know, if you're taking core samples from one location, you can't apply that to the whole of the world. It will give you an idea as to what has happened with the temperature record in that period, and it will go back 400,000 years or even longer. But the point is the equatorial region would have been experiencing a different temperature and climate compared to that of the Antarctic. What we needed to do is take samples of different locations according to the longitudinal lines of this planet, like at 10 degrees south of the equator, 20 degrees, 30 degrees, 40 degrees, 50 degrees, 60 degrees, 70, 80, 90, until we reached Antarctica, and the same for the northern hemisphere. And then we could have got an idea as to what is happening at the different locations of this planet with regards to all sorts of weather anomalies in our history. We can't just rely on core samples from just a couple of these locations on the longitudinal scale of this planet, because we've got different climates, you know, ranging from the equatorial region to the polar regions on this planet. And as a result, you know, we're none the wiser as what's going to go on at, you know, 30 degrees north of the equator or 40 degrees south of the equator. We just don't know. And that's why I say we won't know until one day we realise there are glaciers outside our properties. But before that happens, we'll go into an ice age over these regions, and it will creep from the northern hemisphere and the southern hemisphere towards the equatorial regions on this planet. And at that point, we will be, first of all, in an ice age, and then secondly, we will start to see glaciers moving, and this could last thousands and thousands of years, as it has done already in our history. You know, we've covered recently the topic of Greenland and the Vikings. You know, at one point it was habitable for them. You know, they spent 400 years in Greenland. And, you know, they experienced two bad ice ages during that time that lasted around 50 years each time. The second time they'd give up the ghost. They said, that's it, we're leaving this continent because we're not going to wait another 50 years or so before temperatures come back to, you know, sustaining, you know, life for us here. And they have, you know, evacuated Greenland. And, you know, this has happened in our history. 400, maybe 1200 years they settled, 400 years later they moved. And that's not a long time ago, guys. And it just shows you how things can change in very short periods of time. And that's why I say, you know, one day we could wake up in a glacial period, and in an ice age, and we won't know it. The other thing is, guys, let's have a look at Google Earth, and I'll just explain something to you. Like I say, if I asked you a question, are we in a glacier period right now? You'd probably say no, and the reason for that is because you haven't got glaciers outside your front door. But if you lived anything above 80 degrees on this planet over the northern hemisphere or the Antarctic region, you would say, yeah, I'm in a glacial period. If I said to you, are you in an ice age? Well, again, that just depends on where you are located on this planet. But the point is this, is science won't agree to these matters or terms. They won't say we are still experiencing ice ages and glacial times depending on where you are on this planet. But ice age does occur at a certain longitudinal position on this planet, and so does glaciers exist at a certain longitudinal mark on this planet. Over the Antarctic we got glaciers, over the Antarctica we have glaciers. So you know, it just depends on where you are, and if the climate changes, then you could wake up one day in a glacial period or in an ice age. And that's why I say we should have took core samples at every 10 degrees over the northern hemisphere going down towards the equatorial region, and the same going down to the southern hemisphere, and we would have had a better idea as to where we are located as to regards to what sort of time periods we're experiencing, whether it's a glacial or an ice age or merging into an ice age. Let's take a quick look at the Vostok core sample data, as you can see, taken from Antarctica. So although I want to concentrate on just temperatures from the Vostok core sample, you know, I know a lot of you are going to notice the CO2 rates in parts per million creeping up, and as you can see, we haven't in our history really experienced more than 300 parts per million or over that amount up until recent times, according to these organisations that say, oh, you know, we're experiencing right now 400 parts per million. Maybe we should add to our observatory not just an atmospheric oxygen monitor or sensor, we should also get ourselves a CO2 one to keep track on exactly how many parts per million are in our atmosphere. But I'm going to just quickly deviate here, guys, because this is quite funny. Right, I want to show you what NOAA put out as proof that CO2 causes a greenhouse effects and traps heat. But before I do, just bear in mind, while we're going back over 400,000 years of history of CO2 in the atmosphere and temperature, and yes, we can see that when the temperature goes up, CO2 also follows suit. That could be because, you know, the oceans can no longer hold the CO2 at that temperature and it's released into the atmosphere. But as you can see, when the temperatures start to cool, so does CO2 amounts per million drop as well. But the main point is that on this chart, on this Vostok chart that goes back 400,000 years, it doesn't really rise above 300 parts per million. Now have a look at this experiment that NOAA put out as, you know, their argument against CO2 trapping temperature in the atmosphere. But more to the point, remember, on this scale over the last 400,000 years, it doesn't go above or much over 300 parts per million. Right, have a look at this. This is what NOAA put out. This is their experiment, and as you can see, they have saturated the bottle with 12,000 parts per million. That's a lot more than 300 parts per million, or even, you know, if we take what they're saying at the moment, which is in the atmosphere, 400 parts per million. 12,000 parts per million is a complete saturation of CO2 and not a fair representation of our atmosphere right now. So if the heat does increase in that bottle, it's probably because of the saturation rate of 12,000 parts per million of CO2 in it, as opposed to just the air, standard air in the other bottle. So what they proved here is that one bottle got hotter than the other, and I think there's some big errors in this experiment that they've done here as well. But I just wanted to show you that, because this is the argument that NOAA used for, you know, saying that CO2 traps the heat in the atmosphere. But, well, you know, we're nowhere near 12,000 parts per million in any case. So, you know, there you go. We're only at 400 parts per million, which would only be a little bit over the amount that has been experienced for 400,000 years on this planet. There is some other arguments here to have, guys. Like, for instance, where was the Industrial Revolution that caused CO2 to rise 150,000 years ago? Where was the Industrial Revolution that caused CO2 to rise 250,000 years ago? And where was the Industrial Revolution that caused CO2 to rise 350,000 years ago? Oh, that's right, you little stinkers have chose a point in time going back to the 1760s to say, look, since the 1760s, CO2 has been rising. And it just so happens that in 1760 was the beginning of the Industrial Revolution. Well, if you're going to take a piece of the pie, which, does show CO2 rising well before that, then guess what? That's called cherry picking. And that isn't how you do science. Because if you're going to omit all these other periods of time that where CO2 rises, then that's called cherry picking in my book. And obviously weighting your argument unfairly. The main thing is, guys, we see this a lot. Schrodinger's work with cosmic rays causing cloud seeding, right? If you go and have a look at the data on that, you'll find that CERN done an experiment called Cloud. And what they done is put two gases in a chamber. One was sulfur, and I forget what the other gas was. And they wanted to see if cosmic rays at CERN, when they fired them through the chamber in a mix of this gas, would create water droplets. And it didn't. Or it did, but the concentration rates had to be so high then, it proved that cosmic rays weren't really causing water precipitation or cloud seeding, which we know is a load of bullshit. Because of that experiment and the unbiased way which they'd done it. I mean, this is like getting grapefruit juice in a glass and pineapple juice in the glass and then tasting it and saying, it doesn't taste like strawberries, does it? So, we can't prove that. Of course it's not going to taste like strawberries because you never put strawberries in there to start with. In other words, you didn't put hydrogen in there, you didn't put oxygen in there, you didn't put krypton, xenon, nitrogen, all the other gases that are in our atmosphere, CO2. If you want to do a fair, unbiased experiment, then replicate what it is that's in our atmosphere in the cloud chamber that you built, and then see when you fire the cosmic radiation into it whether it does create water droplets. Don't just use two gases that are in the presence of our atmosphere, because that isn't not again, that's not how you conduct an experiment. I do believe that there was a drive and pressure put on those people conducting that experiment to do it in such an unbiased way. But you know what, if you're going to put grapefruit juice and pineapple juice in a glass and stir it together, it's never going to taste like strawberry juice, is it? But what I'm saying here is simply you need the right ingredients to start with. If you want it to taste like strawberries, then obviously you have to put strawberries in there. If you want to create water droplets, then you have to put something that can make those water droplets, i.e. hydrogen, which is in our atmosphere, and oxygen, which is in our atmosphere. But these two gases wasn't put in there, as well as all the other gases, as well as the ozone, which is in abundance over Antarctica, which is shrinking. Now, is that by means any coincidence that at a time when it should be increasing the ozone hole, it's shrinking? Maybe if they'd have put ozone in that cloud chamber, we would have got a different result. But you know what, we have deviated a little bit here from what I wanted to just show you guys, and that is, if we go to 0 on this chart, we can see where we are with regards to dipping below 0 degrees Celsius. And when that happens, depending on what position you are at on this earth, and we can see that it certainly happens over the Antarctic region. So it could happen at different locations. I dare say it wouldn't happen in the equatorial region, but we can see that it does happen at least over the Antarctic region, and temperatures do fluctuate over there over a long time scale. And we can use this to gauge where the temperature is going to go, even though this core sample comes from Vostok, right? And we can see that at the end here we are about to drop, like we have done, below 0. So even though this core sample shows from Vostok station in Antarctica that temperatures are trending to fall now, this is what we can experience on this planet. I just want to go over to North Skull and show you that what I showed you yesterday with regards to temperature anomalies over the northern hemisphere of this Earth, with relationship to the jet streams right now. And you can see in this region over the northern hemisphere, those temperatures are being held by the subtropical jet stream. And the reason why I'm talking about the subtropical jet stream right now is because the polar jet stream doesn't seem to be there. It seems to have merged now with that subtropical jet stream, and as a result, you know, anything within that ring of that jet stream right now is showing temperatures in the sub-zero category. So let's have a quick look at that. So just having a quick look over the Antarctic region and the northern hemisphere of our planet, and yes guys, I'm aware of the tilt of the Earth being further away from the sun at this point in time, and we are in winter, I understand that, but look at the condition of our jet streams. There is no noticeable difference between polar and subtropical, and if we focus over the centre of this ring that seems to be going around our planet, around the subtropical region, around 30-40 degrees, we will see that the temperature is sub-zero in the centre of that ring right now where the jet stream is. So my point is this: clearly, you know, if we are going to be experiencing on, you know, a prolonged period of time sub-zero temperatures, then it could be setting a trend as to what is coming down the road. You've seen how close we are to going back into those 0 degrees is on the Vostok core sample. I'd love to show you core samples of 10 degrees, 20 degrees, 30 degrees, both over the northern hemisphere and the southern hemisphere, but they don't exist. We can't use GMST temperature records because they don't focus on any particular individual country or point of reference on this planet, because they are taken from all over the world and they're calculated on a mean you know, average line, and therefore they don't apply to anything on this Earth. You know, it's just an average on you know, using all the temperatures on Earth, you know, for the purpose of getting an average, which can't be applied to anything really. But you know, it is what it is, guys. And you know, for the last 20-30 years, you know, our jet streams have been gradually breaking down over the northern and southern hemispheres. We just have a quick look over the southern hemisphere. You can see it's the same story. If we just go back over to temperature, you can see anywhere inside that ring is sub-zero now. You know, we can't use the same argument that the Earth is tilted away. Yeah, you know, we still have the same effects. So there must be something else going on. You know, the southern hemisphere now is in the summer because it's closer to the sun on the orbital you know, movement around the sun, and therefore the tilt is in favour of putting the southern hemisphere of our planet in the vicinity of the sun longer throughout the day. And you can see that the jet streams are not really too different from the northern hemisphere. Where is the polar jet stream? Where is the subtropical jet stream? Again, they look like they're merging. And if we're seeing this on a more regular basis, does that mean then that we are going to be experiencing temperature fluctuations which are going to be similar to what we have seen in our history with regards to ice ages creeping down from the northern hemisphere first, and then following that, over a prolonged period of time, the return of glaciers. I'll leave you to think about that, guys. There's a link down there if you want to support what we do on the observatory. You guys know we do a lot more than just talk about these things. We build equipment and we monitor it, and you know, we're monitoring muons, which are slightly on the increase. We're at 560 per hour per square metre. If you wanted to know what today's rate was, that's it. We monitor the magnetic North Pole migrating. We monitor the high intensity regions of magnetism around the world at different places like California, Kentucky, Hong Kong, Australia, etc. And soon we're going to have muon detectors, Geiger counters and magnetometers in either Brazil, South Africa and the south coast central of Australia. So, you know, guys, if you want to support what we do here, you know, then, you know, that's great. And, you know, I dare say, well, there you go. That's all there is to say, isn't there? Either support or you don't. That's it. It's not mandatory. It's up to you if you want to help do what we do. But we are the only independent observatory, relaying back information to the layperson, you guys. You ain't going to get this information anywhere else, so that's it. At the end of the day, we either get supported or we don't. So guys, have a great weekend. I'll catch up with you at some point, and I'll say what I usually do. Links down there, and as always, bye for now.